Now we're ready to go through some of the steps for calculating one-way ANOVA. When we typically use one-way ANOVA, we're not going to go through these calculations, but it is really important so that you understand the mechanics of analysis of variance that you go through these steps at least a few times. There are 6 main steps for calculating one-way ANOVA. First, we find the overall mean, the overall average for all observations. Sometimes this overall mean, it's sometimes called the grand mean. And then we find all the different group means. Sometimes these are called conditional means. So for example, with the data set on fat mice, we have 1 grand mean, but we have 3 group means, 1 for each treatment and control group. The second step is to calculate the total sum of squares. This gives us an idea of the total variability in our data set. Then we calculate what's called the within sum of squares. For the fourth step, we calculate what is called the between sum of squares. So we have these 3 different measures of variability in our data set. The total variability, that's the total sum of squares. The variability within each group, which we call the within sum of squares. And then the variability across or between groups, which we call the between sum of squares. That's partitioning the variability in our data. Then what we do, using the sum of squares values, we calculate the total between and within mean squares. That simply is taking each sum of squares and dividing by their corresponding degrees of freedom, or number of independent pieces of information. For the 6th step, we divide the mean squares between by the mean squares within. This ratio gives us an idea of the degree to which the data cluster around the group means or not. A higher ratio implies the data cluster more around the group means. That should make sense because the mean squares gives us an idea of the amount of variability between and the amount of variability within. So let's go through a toy example. This is really a simulated data set I created. We have 12 rows, so we have 12 observations, and we have these 3 different groups. So I call them group 1, group 2, group 3. The values of the outcome are simply 1, 2, 3, all the way up to 12. The idea behind this is that you could imagine that each of these groups, it could be different treatment groups. So you could imagine group 1 is a treatment that's a very high dosage. Group 2 is a treatment that's a medium dosage, and group 3 would be the control. The basic mechanics of one-way ANOVA remain the same regardless. So let's go through this toy example. The first step in terms of notation for calculating one-way ANOVA is to specify different indices. Recall that in statistics, we use indices just to keep track of what we're dealing with. That's it. To keep track of our observations, we will use 2 indices. First, we will track each individual from I equals 1 to n, where n, lowercase n, is the total sample size. So here we have an index for 1, 2, 3, all the way up to 12. Those are just the 12 different rows of our data set. But because one-way ANOVA is about groups as well as individuals, we want an index to keep track of our groups. So we will use the notation j equals 1 to k, where k is the total number of groups. For example, in this case, we have k equals 3 because we have group 1, 2, and 3. And we have I equals 1 to n, where n is 12, the total sample size. One way to think about one-way ANOVA is that what we're doing is we're acknowledging the nested structure of our data. Each individual is in a group. There's sort of a hierarchy here. In the same way that you might say that a person is nested in a neighborhood, or a person is, you live in a particular neighborhood and not another one. That's one of the key building blocks and one of the very important aspects of one-way analysis of variance, and why it's a foundation for later statistical models, because we're acknowledging the fact that there are different groups. People, in this case, are members of different groups. For example, the first person in this data set is a member of group 1. The last person that 12th person is a member of group 3. We're acknowledging the structure in the data set. Now we go through the different steps for calculating one-way ANOVA. The first step is just to calculate the means. We first want to find the overall, or the grand mean, and then we want to find the mean for each group. The overall average is simply 1, 2, all the way up to 12, divided by 12. This is just taking all of our values of our outcome, dividing by the total sample size of lowercase n, which is 12. So we get this overall average of 6.5. That's the average across all observations. Then what we do is we calculate the mean of each group. For group 1, the average is 2.5. We just add 1, 2, 3, and 4, divide by 4. Then in a similar fashion, we can calculate the mean for group 2, which is 6.5, and the mean for group 3 is accordingly, if you can see here, it will be 10.5. So once we're done calculating these different means, we can move on to the next step. Now, I just want to stop for a second and say, the reason we're counting these means is that these means are really the benchmarks by which we calculate these different sum of squares. As a measure of overall variability, our benchmark is that overall mean, that value of 6.5. And then for each of the sum of squares, we're going to compare each person with their own group mean. We're going to see, how far off are you from that particular group mean? And then we're also going to ask, how far are you off from the overall mean? With that, let's go on to step 2 in just a moment.